Hello?
Morning.
Morning. Morning, Amanda. Morning, Morgan. All right. Here's the Notion document. Already got it up. Looks pretty good. All right. So the first meeting post GSOC applications. So this week we did GSOC applications. People submitted their things. I hope on time. I got, let's see. I saw that we had 5 projects for the VR, 4 projects, or actually 5 projects for the GNNs, which is in DevaWorm, 4 for the VR, and then 2 for the open source sustainability. So I sent Jesse and Brian, who are going to be the mentors for the, I guess, the open source sustainability and VR projects. At least they're signed up as mentors on Google's site. I sent them a list. So what I've done is I've taken all the applications, put them in folders in a shared drive, and then created a rubric around which we're going to evaluate these. So the rubric, I don't have it up, but it's pretty simple. It's like 5 categories, different topics like clarity, problem solving, and a couple other things. And I don't know if you need, if you need any definitions or if you need clarity on what those mean, I can tell you, because it's like we've done this before in previous years where we've used this rubric. You just go through the proposal, you kind of give it a score from 1 to 10, and then we bring together our evaluations and make a decision. So I think it'll be somewhat clear when you look at the proposals which ones are like 1 and 2 and which ones are 4 and 5. But that's up to, I don't know. I don't want to rely on myself.
Yeah, it's not. It's pretty straightforward. It's also kind of, I think some of the interesting aspects of this is that I don't think we know how many slots we get until after all this process. So it's really just a fairly straight, just trying to rank things and look at them. And I've been in a lot of I've had, Bradley, I think, has been talked to pretty much everybody himself, and I've been in a lot of the meetings with everyone, and there's a lot of good stuff there. So it's if it's the same rubric as it has been, it feels it feels easier than doing some. Sometimes when you're reviewing papers for an event, it's harder. But I think it's a decent process. As a process overall, I feel okay with how Google tries to sort things out. But yeah, and then it's it's nice. Obviously, Bradley's sort of the lead, but it's nice to be able to just talk about hey, what do you think about this? And you kind of see where things are. And I look forward to actually seeing everybody's proposal. So
yeah,
congratulations to those who did submit that, and for those who didn't, there has been decent interest in joining the cohort outside of the Google process. So more on that in the next, the next month, really, because we kind of are preparing all that now, and we have to basically wait a month before we can do anything else, even if we decide the order now, I believe. So
Yeah, so we decide the order and then we have to submit those, get the slots and the selections. And then May 4th, everything is announced. So, but, again, as always, people are welcome to join us with our activities, even if you're not selected through the process. And, it's not that you've had a bad proposal, it's just that, it's always resource constrained with the number of slots. And then, but we don't, we have like a support program over the summer, as everyone knows who's been in the lab over a summer. They know how this goes. We have, usually have like a weekly meeting, at least one additional one in addition to this, where we go over projects and interesting items that would, benefit people's projects, benefit their work, and so forth. So that should continue this summer. Yeah. So good. That's great. That happened this week. So what are do people have updates to give? Let's go through from Amanda to Morgan to Jesse and see.
I have started to message people about the reading group for human use of human beings. I'm thinking just like 1 hour every other week. So like very, very chill, very informal. But still a couple people were like, oh, I'm only available on Saturday.
Yeah.
So and there are a few people outside of this group who are interested. One of my old classmates from the master's philosophy program. So I'm working on coordinating that and getting that going.
Okay.
Still working on methods, project stuff. I think we had a really good meeting last week for Cognition Futures. I like, even though we didn't really get to the second of the two papers, I like that format of focusing on a paper and kind of like having guiding questions. I mean, we've only done that like once, but
Yeah.
it's been good so far. Yeah, I think that's it for me.
All right, that sounds great.
yeah, you've put a lot into the project, and we'll cover that maybe a little bit later. But like, there's been a lot of things that are crystallizing at more project level, and it's always great when people kind of start putting their own like ownership and ideas and development into things, and it becomes more, when more people are doing that. So that's a really cool thing to have happen. And I think that's I don't know. I just wanted to kind of specifically say that that's particularly awesome. So I'm looking forward to that too. And I agree. I like where that's going. I'll say a little more about some other things later. But yeah, good stuff.
Yeah. So yeah, let's coordinate the human use for human beings. I don't know what the format of that would be, but that might be something that we do. We could even devote some of the, well, I don't know if it's efficient, but some of this meeting to it if it's, because we do sometimes over time we kind of have these features where we do, a little bit of a feature, something we revisit over time.
Yeah, maybe like a few points, like not necessarily after every reading group meeting, but at a few points through the book, we can give like a summary. I definitely want to take good notes and make asynchronous conversation possible with this, especially if there are a couple people who like won't be able to make the meetings who have expressed interest.
Yeah, looking forward to that.
If I don't know, like, do you have any ideas, Amanda? Like, would you want the meetings to be recorded like this meeting, or like a reading group meeting that's like it's recorded but is only limited to like the audience, or would you rather not? Like, that's what we're going to talk about later too. But
I think I'd be fine with like recording it and making it a public thing.
Kind of like a aspirational Johann John.
Yeah.
Yeah, oh, very cool. All right, I thought so, but I figured I'd ask. Yeah, we can arrange that. Sure.
Great. Morgan, how are you doing?
Good, thanks. Pratham, I am in the car, so but would love to give me just maybe like a half an hour, and just want to put together the highlights of things I posted this week, just in terms of interesting papers and events. But yeah, looking forward to getting into the Wiener book, and yeah, that's about it.
Oh, thanks. Yeah, thank you. Yeah, I'll call on you a little bit later. We can talk about
Sure,
that.
sure.
All right.
Thanks.
Looks like Pratham is here. Hello.
Good morning.
Morning. You have any updates or?
No particular updates. Just
Okay. Sounds good. Thanks for joining. All right. So, what do we have on the Notion document? Is there anything
Yeah.
you wanted to?
I guess I'll just pull that up here. I'm a little bit limited in my screen sharing ability today, but I can just send this for sure. So as far as like general introductions in mind, we'll say a little bit more about condition features ahead. A lot of my week this week has mostly been about frontier map stuff. And I'm not ready to show sort of, I've been putting things in an actual preprint format slowly, but I've really fleshed out a lot of the theory about it, and a lot of like, what is a frontier map? How would you just putting functional structure to it, like what would it be doing, and how does it relate to stuff? And I maybe I'll go into a deeper discussion of that later. It depends. It depends on some things, and if we want to kind of have more of a nebulous discussion or not. I know you mentioned, I kind of asked about, like, I keep calling it OSI, but I think it's OSF.
Oh yeah, yeah.
Were you going to say something about that later on, Bradley, or?
I actually didn't pull it up for today, but
That's okay.
well, I can go through like yeah, I can just pull it up. I don't know if I'm logged in, but yeah.
There's not, for context, I basically asked her, like, hey, would this be a good place to put this preprint? Because the kind of thing that I'm making isn't like, I don't really know exactly where it would go, because it's a sort of a different kind of a paper or a topic. And so I kind of said, Bradley, I asked Bradley, would this be a thing to put in OSF? So it's not like there's really a lot to discuss about it anyway, but that was sort of a related thing. The main thing is basically, I guess you can kind of see it here. NYCWiC is basically going to be, we're trying to wrap everything up this weekend. Bradley has sent me his thing. I think Ankit is sending his today. I'm not sure if Brian's going to do I'm not sure what Brian's doing entirely for it, but that's fine because I'm basically going to be wrapping up things there. And I guess I'm just going to bridge into this now. But we have, just as a reminder, we have this was basically our abstract submitted. I had to boil it down quite a bit because I wanted a 50-word abstract. So it was like just key points from this. But basically, I just put Bradley's link there today. they're just gonna go Bradley, Ankit, potentially Brian, and I'm gonna have a little bit of I might even do 2 on myself because talking about the paper, I don't think Jen's gonna join us today. Talking about the paper here, not paper, this presentation. There's a lot more that could be said on this. I think I'm gonna do like a shorter pre-recorded video and then a longer one depending on the timing of things. That basically to basically fit the timing that we have, because right as it stands right now, I think this is like around 9 to 10 minutes. We'll see what Ankit does. And the thing is, even if they're a little bit longer, I can either shorten them up or just say, hey, you know, unlike the, anxiously kind of trying to interrupt the speaker, hey, 5 minutes, 1 minute, you know, of you're out of time, sir, you know, it's you can just move the video towards the conclusion.
Yeah.
so that's kind of an advantage if there's need to be. But I think I might make. Well, I'll just do that on myself. I'll make a longer one where I go a little bit more in depth with this, and Jen's working on this, and then good stuff here for the NIH, the data policy stuff. Maybe we'll even tease a little bit about the ethics board projects. I don't know where it is right now in this, but yeah, actually I think I'll do that because that'll easily be. I'm sure Ankit can, depending on what he sends me, you know, there'll be plenty of time here. So we're basically covered for that. The only thing I have to do for this, and I have it generally, but I have like the main slides, which will essentially just be overview slides or intro slides to drop in Bradley's or Ankit, the segments, basically Bradley's, Ankit's, and other segments into that order. So it's good. We're in good shape. Even if for some reason, like at this point, even if Ankit can't do it for some reason, which I'm very okay with Ankit, and I have a sense that it'll be fine. Even if not, we're just fine. So I'm happy where we are. We have a lot of things fleshed out. We have a lot of material to cover as always, and I guess let's say oops, no, go back here. I did mention before if people want to stop in and be a Slack moderator for the event, there really won't be a lot of opportunities. There won't be a lot of opportunities for people to have too much trouble, but it can never hurt to have people looking on lookout, you know, if someone flagged for help somewhere or something, and you know, so that is available. It's a little bit less robust than I don't want to say hope, but it could have been. We did make a discovery that, I made the discovery that within Slack, there's a default, like the first channel, usually called general, is where everyone is entered upon entry. Like you're automatically put into the general channel. And there may be some ways to adjust that, but the original general channel is you have to be entered into that. Like when you join the Slack, then you can change the title, but you can't delete that channel. We found out that the title was changed and the channel was partially archived, or at least made, like, it was only like, it wasn't called General. I kind of want it to be called General, but that's fine. It's called like NYCWiC 2023, and it was originally like NYCWiC 2020 or 2021, and then it got lost, and I changed it around, and so now everybody's being added there properly. And people were saying, "Oh, you don't really use Slack." And I'm like, "Well, for the last 2 years, the people who've been added to Slack have been added to a relatively archived channel that nobody updated." So unless we're taught to come to another channel, they were never doing anything. So I'm really curious to see if that affects our Slack usage this year. So that was a little bit of a discovery. I will be participating in the My Job is So Cool panel, which is fun. There's sort of a grad school panel and there's like a jobs panel, you know, and it's cool because I kind of offer a unique situation where I'm doing stuff in this lab. I'm doing like my actual day job. I'm doing a startup-y kind of thing with plot twisters, and it's a really cool panel. Also, shout out to the host of the panel, Michael Baumgartner from University of Albany, who is a true champion and one of the first people I met. First time I remember Mike, I was like in person. I was speaking at like an accepted students or prospective students open house kind of event, and I was looking for a water bottle, and he just shows up with the water bottle, and he's like, "Hey, you need this, like, nice to meet you. Have a great, like, thanks for speaking at this thing." And it was just really cool. It was like, 'cause Mike's this extremely helpful person, and he's been, you know, it's not mandatory that people from the university or the department come to this event, the New York Celebration of Women in Computing, and it's like, it's great. It's someone I look forward to working with there, and it's always great. And I'm glad he's moderating the panel. So shout out to Mike, and shout out to the organizers of the event. It's wrapped up. It's always been tough to managing the hotel and all the details I won't get into, but like managing the venue and coordinating stuff and all the things. And I think I have a fairly light lift compared to. I've done some media stuff and communications, and I've tried to help with a mentoring program, but there hasn't been it's not been a terrible thing for me. So I've tried to, help out how I can. But it'll be really fun this year. And for those who, if you are volunteering or interested in volunteering or interested in the event in general, there will be opportunities next year. And I would really like to potentially add a virtual component in some form. So that's kind of why I'm mentioning this. NYCWiC predominantly has not been virtual, with exception to like 2021 because of pandemic stuff. But there's going to be some changes in the next year, and I don't think I'm going to be able to be a lead organizer, in part because I'm not based in. It's predominantly been around like certain parts of New York, or like around the capital in Albany, New York, and I'm not based there right now, and I don't think I will be next year. But I would really like to make a virtual component a little bit more accessible or just differentiable that way in the future. And to that end, we'll see. If people are interested in potentially having some leadership in contributing to that, either as a like you keep in mind, NYCWiC itself is not. I always bring an ethics thing to it because that's what I do with the Society Ethics Tech team. Like that's sort of the mutual relationship that we have with that. But it's predominantly just a computing conference, or Women in Technology conference, Women in Computing specifically. So for those who come through the lab or see this later on or thinking about it, just kind of a general nod. Like if you have some passion towards developing or contributing or shaping an event, and you like the ethos and the idea of this, either as an organizer, as someone who's in current technology, or as someone who is interested in the Society Ethics Tech team stuff too, reach out to me, because in 2 weeks, well, I guess a week and a half or so, we will. I'll put it this way. If you've been to conferences and events, especially smaller ones, you know that it's really just a core group of people that make it happen at all. And there will be some people who've been running the conference that won't be able to do it anymore. So there's some major leadership roles that are changing. And as I said, I'm not going to be able to be like a complete general chair for the event. But it's critical to gain and maintain some of the interest for people who are wanting to build out stuff over the next year for annual events like that in particular. So I think one of the things I'm going to be doing, it's sort of been unofficially, it's not like I'm deputy of, I'm not deputy director of getting people engaged for next year, but as someone who is vested in having a conference happen next year, I am really trying to find ways to find participants to build it out. So that's a very nebulous pitch of sorts. But if that's something that you're interested in doing, please reach out to me. Outside of that, thanks everybody for your contributions so far. I'm looking forward to it a lot. It's always a good time. I think it's only going to be me there in person. I think other folks are traveling or not really going to be able to make it, which is just fine. But I will have videos. I will have the Slack. I will have, if anybody has any things they want me to reference at the event, or I may try to wear a lab T-shirt or something. Like if there's anything you want me to represent about the lab as well, like let me know and I can have a little bit of promotional space for it. But in general, I'm expecting to wrap that up. I'll have all of my videos done by Sunday, and we'll be ready to roll Friday morning, Friday afternoon, basically, this upcoming Friday. So it's less than a week away, and I'm happy with what we've done so far. And thanks everyone for making that happen. So, any questions about NYCWiC before we move on to other stuff?
No, congratulations to everyone involved. I look forward to seeing the session. I don't know if you are you connecting from, are you offering like a virtual presence there, or are you just doing the thing in person? And then, because I'd like to have some record of it for the lab, or at least have interactions from the lab if possible. I don't know.
Do you mean like for the video itself? Will it be recorded?
Yeah.
Like will the presentation be recorded?
Yeah.
That's a good question. Because last year I think we basically just
we recorded it.
Right.
It was it was like hybrid, I think, where we had like people in person and then people on Jitsi, like we had a Jitsi space like this. And then, it was a little bit difficult, but we do have the video for that session. I don't know if that's something we want to replicate or in some other way, maybe.
I am open to basically doing that again. I think it's basically going to be screen sharing on Gisty. I haven't seen exactly which room I'm going to be in yet, but so long as there's hopefully decent Wi-Fi there, that's what we're going to do. I do want to yeah, let me I'm confused at the moment as to which like time slot I'm in for that versus the panel and other stuff that I'm doing there. I'm trying to help out how I can with different things. I will send out a like email or something in Slack to people who may want to be virtually present. Like I know you might want to be present if you're available, probably.
Yeah,
And Ankit, depending on the timing, and Brian and others. Yeah, I'll that is a good point. And I sort of implicitly considered assume that, but I should reach out to like some of the programming saying, hey, can we do this or incorporate some, just so there's a little bit of feedback. There should be like some time for question and answers and stuff like that. So I think it'll basically be last year without any everything will be pre-recorded, which will make it a little bit smoother. And I'm gonna have those videos just pulled up basically. But then having a virtual component where there can be some feedback and live questions will be good. And I think it should definitely be doable kind of in the Gisty sense like last year. So that'll be good. Yep. Excuse me. I don't know if, whoops, I don't know right here. The next thing I will probably cover will be like frontier mappy condition futures related stuff. I don't have a whole lot of other stuff today, but I know Morgan wanted to give an update too. So I don't know if Morgan's ready yet. I might defer to that as I get some other stuff ready in the background, but I don't know if it's a good time or not.
Sorry, not quite.
Right.
Okay, no, cool. That's no worries about that. What did you want to before I launch into all my stuff? I keep hitting this. Sorry. Bradley, what did you want to cover today? I'll kind of just go through this chart a little bit. There's a few silly things of new business that I would talk about, but I don't know what else you want to talk about yourself today.
Yeah, I'll share my screen here. I have a couple things I want to talk about. I also want to do an update on project management on the class, and then we have some things to follow up on from last week. So let me share my screen actually.
Okay.
I don't know. Well, I guess I can do it like this. Okay. All right. So first thing is there's this, and this will be in that table that we have. I think it's in there, but this is still ongoing. This is due the 19th this month, so I don't remember what day that is, but that's about 11 days away. So we have this essay competition from FQXI, which is foundational questions. It's like there's it's physics oriented, but I think the question they're asking is pretty open to all sorts of different approaches. So we have it's open to submissions until the 19th, and we basically the question is how could we make science different? So it looks like there's some entries already made here. People have already submitted things. So some ideas here. How could science have emerged differently in order to have solved open basic enigmas for humankind today? Could science be different and improved? Yes. One specific proposal. Chronicles from a simulated science. I mean, people just kind of are more creative than others. So there's, how could science be different? There looks like there's just a list of oppositions here and debates. How the Nazis split modern physics and how it could be reunified. A new vision for science balancing stakeholders and fostering collaboration. So there are a lot of ideas here. And if you're interested in participating, we can we could do a group submission, but I guess it's also possible we could just do separate submissions and be done with it. And I mean, organizing a group submission is a little hard to do to get everyone on the same page. So I'm just leaving this up here so that people are aware of this competition, reminded that it's due pretty soon. So if you're interested in participating, go to this website and qspace.fqxi.org competitions, and you should be able to submit something. I don't know what the word limit is. Let's see.
Yeah, I was just going to ask that.
So let's see. There's a character limit of 25,000 characters, which is like 9 pages. Yeah, so I mean, you can. I wouldn't make it like 1 page, but you can't go over 9, and it's a standard 8.5 by 11, 1-inch margins, 12-point font. So that's. I mean, they really are specific with the formatting, but that's typical formatting. So, and then it's supposed to be anonymous. So, and it has to be submitted in English, of course. But yeah, I think that that would be interesting to see what people come up with. I haven't really given it much thought, to be honest with you. I'm not. I've given a little bit of thought, and then I've been doing other things, so I don't know. We'll see if this happens or not on my end. But I know that Hussein expressed some interest in doing some things, or doing something. I can't remember what the topic was, but again, it's coming up. It's coming up.
I'm interested in doing something. It will mostly be a matter of finding the time to do it. I have some ideas, and I think it says to do the 19th. Is that right?
Yes. So it's 11 days from now. Yeah, no, it's tough.
Because there's some very natural on ramps for me. But it's incorporating some of the stuff. The general spoiler would be, it's not exactly where we left off with Fuchs about, okay, how would we do science with like dual aspectivity as the foundation of it? But it's sort of similar in terms of some of the like it's kind of adjacent to that concept. And there's some ideas I have about like fleshing out things like different I guess sort of principles that could be instilled into the process of it all. So that's sort of my idea. I'm actually talking about it, thinking about it now. I'm actually more motivated than I was before. It'll really just be, I think I'm just going to have to make a choice at some point. I would love to have a draft of it before the NYCWiC event. Will that happen? I don't know.
Yeah.
We'll see.
All right. Yeah, great. So the next thing I want to talk about is this. This is something I found on, I don't know what it is, uploadvr.com, I guess. And this is John Carmack sharing his VR vision. So this is a podcast. So John Carmack shares his vision for instant VR and Bosworth podcast. Bosworth worked for Facebook or Meta in some of their VR stuff. John Carmack, of course, is a longtime innovator in video games and in VR. This is the newest episode of Meta CTO Andrew Bosworth's podcast reveals a range of technical and strategic insights from VR expert and independent AI researcher John Carmack. And so Carmack was at Meta for a while, and he left in December to focus on developing AGI, actually. After a decade-long run helping shape the direction of VR development at Oculus and advising executives at Facebook. So I don't know if there's what the content is here. Near the end of the podcast, Bosworth asked Carmack a few questions, starting with the following. Your vision for Quest hardware has always been light, cheap, and fast. If you had to pick one vector to push for future VR hardware, which would it be? Carmack declined to reduce his answer to just one vector of improvement, and outlines a suggested path for Meta's next steps in VR, focusing on reduced friction. And when they say friction, they mean like, points where you get stuck or points that are, difficult to move forward with. So, like something that's light, cheap, and fast is reducing friction, I guess. Here's a lightweighted transcript. So, if the VR experience about how tedious it was to start, or how much glitchiness there was, or the limited availability of the things you wanted to do, if that was on your phone, what would your phone be like if you had to set up an acknowledge guardian, which is the thing you have to set up your like spatial perimeter? If you've used the Meta Quest, you know what I mean by guardian. It's just you just define the space that you're operating in every time you had to start it up. If you had to wait for your controllers to wake up before you could start doing inputs there. So getting to that point, not just light and cheap, but it should also be instant. So instant is reducing friction. You should just be able to pull it up and put it on your head and just glance over there to look at something as easily as you would look at your watch. I think that the level of feedback and the lack of latency is critically important, but then it needs to be just be able to actually do all the things that people want to do. I keep saying how VR needs to displace all these other devices, which I don't know if that's something we won't necessarily want, but that's the vision. So VR replacing like your laptop or your phone or whatever, which is, you could use AR or XR in those cases, but it's hard to see that happening in the near future because I think the problem with VR is they've always tried to find the killer app for it, and that's not happened. But the question is whether VR should be replacing everything we're doing, or along with augmented and extended reality, or should it just be its own thing? And that's a question that if you're thinking long term about the technology is very important, because we've had a number of hype cycles where it's been like people thought it was the future, and then they found out that people didn't really accept it as it was being developed in that current time period, or it was something that they just couldn't find the killer app for. And this has been a persistent thing. So this is an interesting question, a core question for moving the technology forward. For the early adopters, the people that are at the bleeding edge, they buy everything. You get a VR headset in addition to your second, third, fourth TV, and your tablet, and your Chromebook, and all these things. But to get to the whole world, it needs to replace those things. So in other words, to get massive adoption, it needs to replace all these things, which again may or may not be true. I mean, we have, I guess, at one point the tablet, the Chromebook, those things were not like fully adopted, although your tablet and Chromebook had to do a lot of things before they got adopted at the levels that they have. So this is something that, we could debate about. It needs to go ahead and say, well, if you buy the VR headset, you don't need to buy this Chromebook. You can just attach a keyboard to it. You don't need to buy this extra TV. You've got your big screen theater there, and so forth. And so that's, I don't know. I mean, that may or may not be, just from a practical standpoint, possible. but it may or may not be the right strategy going forward, but that's what he's advocating. They can be cheaper than cell phones in some ways. They can have all these abilities while providing the big screen value. They can have the unique advantage of virtual reality with the spatial movement and hand tracking and the things that we're doing while subsuming all these other things. So this is, kind of salesmanship for the idea of VR, but also how does that fit into the marketplace? And what do we need? What are the things that are really interesting about the technology we can use? So hand tracking is great. You can't do that with a tablet or with a cell phone necessarily. You can do that in VR pretty easily, but you have to integrate things in that space. So, and it remains to be seen whether that's something people will accept or adopt.
Can you share the link to that article here?
Yeah.
Or ideally here or in Slack. I want to make sure that's cool. I have some thoughts about that.
Okay.
What was the background? John Carmack has worked predominantly with Meta.
Well, he's recently worked with Meta. He's worked with a bunch of companies, but that's his most recent stop. So he's worked with that technology, specifically the Meta technology that they're doing. So there have been a bunch of different approaches to VR over the years, and this is one of the cheaper. One of the ones that have been more oriented towards consumers. Yeah. So
I'm gonna do something that I have wondered about doing, and I'm gonna vaguely do here, and bridge finally orthogonal research education lab and K-pop or Korean pop music.
Right.
Because there's there's a slight kind of humorous take, but somewhat relevant take. For those who may not be familiar, there's in and I'm going to pull up a Teen Vogue article. In K-pop music, you typically have a concept for a group, and there's one group called aespa or aespa, where you can see these are real people. These are the actual people. 1, 2, 3, 4 here. And they're the first group to have these sort of digital AI avatars in the background, and they part of their deal is that they are this sort of inherently embedded in a virtual world, and it's been interesting because when they came out, I am by far not an expert on this, but I do know about them a little bit. When they came out, they were kind of a little bit, I don't want to say laughed at, but not the most. The way the members of the group had to sort of answer questions about, oh, so you have this your AI avatar, and you have this mission. You can see this article here. It's there's sort of this sense of a cyberpunk crime fighting aspect to this group, where they're fighting this villain, and they have special powers where they're trying to reconnect with their AI avatars and all this stuff. And but it's kind of more originally it wasn't taken very well, and now they're a little bit more popular, mostly because of their music and what they've done. And I guess why I'm mentioning this is that it's kind of a little bit of a sense of, I think when it comes to reducing friction, when it comes to acceptance, it feels like virtual reality keeps making these swings, like at if you're at a bat, like baseball analogy, they're swinging for these different things that come up, and how to get acceptance and how to get adoption. And it feels like it's always on the verge of, I'll go back to the article here. It feels like it's always on the verge of being able to do that, but I'm quite curious as like if there's actually, I don't think it's actually a meta device, but there's a device that was like literally looked like a big, like kind of a big pair of oversized goggles, not like a full headset, but the appeal to the goggles was basically, yeah, like you just have an extended space that you could operate in. What I'm really curious about, and I don't think it says it in here, I'm trying to read this here, but I don't know if you've heard about this or seen it with anything Bradley. Is like, I think you mentioned hand tracking. Is that what you mentioned?
Yeah, hand tracking is one thing. So there's a spatial manipulation component. You can manipulate things in different parts of space.
Well, I honestly think, and I'm really curious what Meta does with this, but I don't know the latest on this specifically. Because I personally, from a use case scenario, I have been looking for something where I could basically write effectively in a virtual environment and like either transpose it across screens or like be able to do it. Because what I'm doing with my personal setup in my office is I have like a large screen and then a side screen for laptops, and I interplay between them, and I have a few, like I have like an iPad and other stuff too, and it's like I totally, like, to me, functionally speaking, why I would want to do what was mentioned in the article is if I could just take my desktop setup and put it in VR and just manipulate text across it. And I don't know if there's really a lot of work in that. Like I've seen video games, I played a lot of like some string games. I've done some things with like, but I don't know anything that like physically writing or doing something that would combine a keyboard input and a writing input in that kind of like an office-y space. And I know Meta's working really hard to become the office, have your, be that, like a lot of their products are geared towards, well, actually, we're not going to do computing video games, we're going to do your virtual life in here.
Yeah.
And I just haven't seen, I'm sure there's something there, but I haven't really seen can I take my pen, can I take my VR hand pen and write something and move it to a virtual document, or outside of it, can I send an email, can I do this and that? Like actually in a virtual environment as opposed to using these apps that are kind of adjacent to it.
Yeah.
So,
well, I mean, the one thing I've been doing with working on things in VR is to use. Meta has an app, Horizon Worlds, and it's like they have a workspace where you can go into a workroom and you can you cast your desktop to the screen in the virtual environment. So you have like a little workspace, and you have a whiteboard. You can project the the screen capture up to that, and then you can hook up. I use a magic mouse. I plug it in, or I connect it to the headset, or actually to the headset and to the PC or the Mac or whatever I'm using, and then I type out. You can write something on your on your computer, and it'll project to the virtual world. So you have that space. You might use an intermediary like Google Docs. So you can do that, but it's sort of clunky in the way that it's set up.
Yeah.
It's not seamless, but you can do it. Go ahead.
Because I'm looking, well, I guess I'll share my screen again because
Right.
I should do more with that space. But I've had a sense that like it just won't really
Well,
do
it's
what I
not,
want.
it's not the best. Like it doesn't. I
'Cause,
mean, like
it's cool, but
as they'd say, there's a lot of friction involved. So you have to set it up, and there are like 6 steps to get it to work, and yeah. So Vrushali said, we can write an error and it will be seen in VR. I've seen it in my workshop. Yeah. So it's like something like this, where you can do things collaboratively. But again, there is a fair amount of friction in it.
So when, I guess my curiosity is like, is someone wearing a headset and typing on their laptop when they're doing this?
You can get, like, if you have a wireless keyboard, you can hook it up via Bluetooth, and it'll come up, like my Magic keyboard will come up in the VR environment, so I can see what I'm typing. It does project, so it's like there's sometimes like I hit a key and it's like in the wrong row of keys. So that again, it's like it's not perfect, but you can do that. You can do something like that. So it's like you want to have the interaction devices. You want to have them work. Like kind of if you hit the button, you want to have it be natural. You don't want to have to like kind of take your headset off a little bit and peek underneath or that sort of thing. It's it is like I said, there's a lot of friction, but you can do it. You can put it together. These are great. Like I think there's a potential though for doing virtual meetings this way. I wouldn't try to do like that as the default, but it would be it's getting there. It's getting there. It's not
I
quite there
love
yet.
I love how much, and I say was a big amount of like snark, I think, is in my voice. I love these gestures of like, they reminds me of like early, like very like a little bit of Sims, a little bit of like other like virtual worlds where it's like is very, very like everybody's making these like same expressions, like, oh, I'm just gonna wave my hand this way. And it's like,
Yeah.
that's cool. But no, like I'm actually curious. I should really experiment a little bit more for the sake of there's something I need to look at about this where like this is appealing to me because I would like my desktop to be like, you can literally have the classic virtual machine of accessing your desktop on other devices. Like
Yeah.
that's many people have lived their entire lives that way and like digital nomad stuff for sure. But having a version of this, and also like what I'm curious about is, could it be like if I was hosting an environment like this, if we had, I'm not saying don't worry, I'm not going to make any of our meetings be this way. But like, I'm curious how this, like a situation like this would be recorded. Like if we were going to theoretically host a lab meeting or a Curation Futures or something in a group like this, I'm curious how it would be recorded and how you'd control the focus of the camera about what's being recorded to put it into basically a two-dimensional format for viewing later on. Because
Yeah.
like, I'm sure there are many things about that happen, or like even 3D or like virtual, like recording the whole workspace. But I don't know anything about that right now.
Yeah, I mean, one way is to get like a capture from the headset to like a PC and then just record the screen there. So it comes up in a like a capture device, like maybe like a browser window or something, which isn't ideal, but it'll work.
I have to imagine like part of their reducing friction will actually be what I just said in terms of if you could make it like just these screens, like that would be like that. I think that's what we're coming to, where you could have instead, when someone's talking, they're light up, or you pen to them, and you have the option of centering them or not, and being able to do that in a way of controlling that. And I wonder how much. I wonder where we are in that. I have yet to really do this, and it's so funny because like I got everything to go right up to this and haven't done it, but I really should. That'll be fun to look into. So
Yeah.
between that and are obviously Google Summer of Code projects that are kind of doing with this, I'm really curious. I think that's not to tip my bias too much, but I'm very curious about. That's actually a K-pop joke, believe it or not.
Yeah.
Bias from it. But I'm really curious what happens in the Google Summer of Code projects this way.
Yeah, we're not going to be building any like infrastructure like that, but we'll
No.
probably be able to get to something that's interactable, and then we have to figure out how to. And then this stuff is changing all the time. Like they're coming out with different ways of doing this. So, yeah, that's we can talk about that, offline or next week. More as we think about it. So I encourage people to think about that. But I actually have been wanting to give a presentation on some of the things I've been trying to do with facilitating some of that, but I'm not quite there yet. I'll have to do that in another week. So,
yeah, happy to like, I don't know, not help out with that, but happy to hear more.
Oh yeah,
help with.
So the last thing I want to talk about is Grid World. This is Alexander Miller. This is I guess it's his blog, and so this is an article on it's kind of a being interested in graph paper and kind of modeling and mathematics. When I was a kid, my dad gave me a piece of paper with a grid printed on it. It consisted of larger squares than a standard graph paper, about an inch in size. It was basically a blank chessboard. And then my dad helped me draw an imaginary island within the grid's boundaries. I sketched the squiggly coastline of my island, forming a splattered blob shape within which I added the obvious necessary features of all mysterious islands require. So I had fun with it. There were variations on this game. Sometimes the map was of a completely imaginary place, but other times we mapped a known area, like our backyard, and added fantastic elements. So his dad showed him how to make that addressable, so you can, if things are in a certain grid, that's an address, C2, B4, and so forth. So this is like, what is this? This is creating a coordinate-based index, but more specifically, it's teaching people how to build a piece of code that would be able to recall or retrieve those pieces of information in space. So this is an interesting way of thinking about, starting someone off with a coding problem where you give them a piece of graph paper, they draw something out with features, and then you have an addressable system of points, and something is within that point within the interval, and you can then do computations like that in that space. So this was graph paper, and sometimes it makes it easier if you do things like this with a physical medium, like graph paper, sketching something out where you're not really necessarily writing it in code, but you're just like kind of conceptualizing it, and it helps people, like, I think, get their head around some of these problems that we talk about in coding. It's just kind of hard to sometimes it's hard to understand them as a line of text or lines of formatted things. So this guy became obsessed with graph paper and that whole medium. And then around the same time my dad showed me the grid map game, I started using a computer. In our house down the carpeted stairs, there was a light wood desk where we had a Power Mac, which is an older Macintosh. This is, decades ago. Through the machine's clunky low-res monitor, I came to witness a grid come to life. This is, of course, we know this from artificial life experiments and cellular automata, and this is an example here below. So HyperCard actually was a a version of building programs. It's actually it was pre-HTML, but it operated a lot like HTML. It was a program for creating programs. I don't know if people have heard of HyperCard, but there's a link to that in the article. Something Steve Jobs came up with. It was supposed to facilitate interactions with programming and building programs, and it certainly was a precursor of HTML, although it doesn't really have a direct connection to it. HyperCard allowed you to draw things in a monochromatic format, and so then in 1982, when designer and artist Susan Carey was commissioned to design a set of icons for the new Mac, she brought a small graph paper notebook and sketched some initial ideas using the cells of the graph paper to represent pixels. So again, you have this ability to think computationally. It kind of comes from grid paper. And in fact, in the first computers, they often would use graph paper as a proxy for some of the computational stuff they were doing in a digital format. So, so this just kind of goes through some of the grid, the aspects of grids and grid paper. The grid is the lens through which we understand the natural world. It abstracts over the messy reality of blobs, fluids, particles, trees, mountains, oceans, and streams. Seen through the grid, all the objects you touch, all the landscape you see, all the experiences you live happen in the same place. That place has a name, space, and it is measured, quantified, and standardized by the grid, and by its regular meter. If you've ever heard of Flat World, which is a series of books on creatures that live in like a two-dimensional world, which is flat. There's no third dimension. There's no height or depth. And then they get visitors from a three-dimensional world, and they come down, and like it's inconceivable to the two-dimensional denizens what that three-dimensional world looks like. They know the two dimensions, but they don't know what the third dimension is. So this is like, grid paper, but you're thinking, first of all, you're abstracting things that are continuous to something that's discrete. But secondly, you have this aspect of dimensionality. So you could have a third dimension that's a grid, but you can decouple these things as well. So this is an example of some fluid-like object, or they almost look like, collective behavior of different little organisms, maybe like worms, but they're all exist in a grid. So each part of the body is part of, is a grid cell, and it's moving across the grid, but it looks like it's flowing continuously. So you can, represent things in different ways through grids. And so, it does get to that. We've talked about the idea of things being discrete versus continuous. And so this is, of course, a classic example from computing and computer science, where you're taking something that's a continuous phenomena in nature and you're making it into a grid, and that's serving you to like basically design computations around it. So there are a lot of grid-based games. You kind of get introduced to the power of grids through play. So there's something like Battleship, or even chess, where you work from a grid, and that's your world that you're operating in, and you learn how to do things strategically through the grid. And so this is really interesting how he makes that connection with some of the games we play when we're young, get introduced to when we're young, and we kind of have that mental model of the grid. And then, that's a natural sort of extension of computation and how we do computation. It's not the only form of computation, of course, but it does, give you some, a way forward in that. So this is from the HTML review. This is a new article. So this is an interesting article. I found that interesting. I thought people would maybe want to discuss that more. Okay, yeah. Flat world does not equal flat Earth necessarily. Yeah, I mean, it's just, a joke. But yeah, the whole idea of flat world was that it was like a two-dimensional versus three-dimensional world. I think Carl Sagan talks about it in his Cosmos series, where he does a demo of like where there's grid paper, you have these this world where there are these creatures living on a grid, and then they get introduced to like a three-dimensional object. Blows their minds.
Yeah. Yes. Is that related to like the Tesseract stuff too?
Oh, I don't know.
Anyway, yeah.
Well, Tesseract is like a four-dimensional thing where it has like a cube inside of a cube. Yeah.
Conversation about like what would it look like to kind of go down between dimensions, and how does this look? And okay, cool.
Yeah. All right, that's great. So let's see. Morgan, are you ready to do your thing now?
Sorry, not yet.
Okay. Well, I have some other. So I guess, Jesse, did you want to do some things with the?
Yeah. I was looking for another GIF for some other things that came up there, but actually I'll show this quick GIF about the ASPA members dancing with their AIs alongside them, because it's
okay. There we go.
That's sort of like this meshing between the two things. And again, I mentioned them specifically as like, oh, it's unusual to talk about that, but also like there was a lot of weird. When I first heard about them and I was really curious, because you're basically taking a highly visible celebrity or a group that could become very highly visible, and making them talk about this relationship between their digital avatar that doesn't exist. There's nothing based. It's literally a fictional character. It's based off of it's like fan fiction. Like it's all story based. There's no mirroring of a real person, just to be clear about that. So it's like, how are you going to have your group talk conceptually about this thing that's embedded in a digital world that's like evolving? And there's actually a lot more praise for the concept now, because like now NFTs have hit and all this like virtual avatar stuff have hit, and there's a lot more, it's a little bit less. I guess my point, just to read my point about them, is that this group at origin was a little bit questioned even within the industry. And now there's a little bit more movement in that way. And I'm very curious to see, I think ISPA, the group, will be an interesting barometer if other people start duplicating that, or if that becomes more of a mainstream thing, or if it's still kind of a fringe stuff that's like partially accepted because, it's sort of like, it's one of those things. I'm kind of like, I don't have a very good diagram for this, but this is actually related to my frontier map stuff, and oh boy, I don't know how I can possibly show this. I have it. I don't know if it'll be of any use to see it all. Can you?
Your camera's not on. Yeah.
Oh, it's not letting me use my camera for whatever reason. That's a bit of a bummer. Let me try one thing, but just to kind of talk about it, I guess, is because part of the frontier map, like work that I'm doing is what I'm trying to get at is I probably should give this a lot more context, but given like the timing and given that like like Bradley knows what frontier map is, but probably nobody else really does. And one of the things I've been doing to that end is trying to demarcate certain like influences or points in time things happen, and I'm creating this sort of like defining some things about like landmarks and defining some things about the way I want things to be.
I'm just drawing out what you're saying here.
Okay. Maybe I can I just share? Oh, you know what? I don't know if you can easily put like a picture into that background or not, because
it's going to be hard to do.
So to very briefly talk about it, you can kind of see, is this visible at all?
Yeah, great, it's perfect.
You can kind of see, like, this is the now, and there's sort of a short-term current era, there's a previous era, there's a past era. And what I was talking about the big segue connection I was trying to make, and there's actually, this is not what I want the frontier map to look like. Just to disclaim it, I was trying to visualize a specific process. But if you're looking at a specific concept, one of the things I wanted to get at is what are factors or influences that may keep this concept, like in this case, having whatever we want to see over here, your digital avatar or like VR stuff in general, however you want to say it. What are factors that would kind of keep it in a status quo, or like keep it as accepted as it has been? You could say this is almost like an Overton window, maybe not, or like technological Overton window, hashtag technological, socio-technological imaginaries, I think is also like a relevant term here in the field of study that I'm not familiar with as much. But like things that either move that concept towards acceptance or predominance, or move it away from it. Like we kind of, there's adjacent concepts that I'm talking about too, in terms of like, like winters and summers, about like AI winters and summers and things like that. and this is like a very not, I'm personally showing this because it's an outdated, like not really accurate diagram of what I want to do. So I'm not like feeling too much pressure about that.
Yeah.
But also it's the sense of like, I think ISPA is quite interesting in this way as far as how what's the buy-in. And the thing is, like, a major factor, which I'll kind of move this a little bit so you can see the actual GIF, but like, I know it sounds funny, but like, ISPA was invited to Coachella, which is a major music festival in the West, in the United States here, I think.
Yeah.
And they're like, this, like, it's in it's not quite like butterfly effect, but in a somewhat legitimate way, the success of this musical group is going to shape a little bit of how much it's seen as normal to operate within these environments.
Right.
So that's an extended stretch. But my point mostly is my point mostly is like the work I've been doing in Frontier Map is demarcating and kind of creating a bit of structure to like how do you go from nothing to developing the map. And I have these sort of structures, or these like I have like I'm getting to like an actual to-do list, or like an actual I don't want to say algorithm, but the process by which you're going to do it. As in, I'm kind of picking, I'm basically imagining picking it. It's kind of a way of describing how to triangulate enough, both the relationship between like some concepts and then a related field of study, and how you would go through identifying things about that concept. Like imagine you have no real context for the field of study in general, picking potentially a concept to start with, and then going through these things about key figures, about ideas and concepts, about debates, about paradigms, about the schools of thoughts, about sort of summer winter periods, about these sort of eras of past and present, and like the contextual, like the short term and the potential near term things, and like breaking these down. I'm kind of rushing through this stuff now, but it's I really like it because what it's doing, and what it's bleeding into some other things that we're talking about. But suffice to say, I really like that this tool continues to be both like platform agnostic, and also as I'm fleshing it out, I'm realizing and at making it inherently discipline agnostic, and making it less about, it's not going to be the tool as I'm envisioning it is not it's not going to be a if you do this process you will know this field. It's much more about identifying the relationships between sort of all of these things happening in sort of the idea possibility space, or like the cultural space, and then understanding sort of your relationship to them, and trying to understand, getting context between the relationship between those sort of ideas, and making them into kind of these landmarks to reference as you're exploring the field. So the outcome is much more not to say in like a prescriptive or deterministic or dogmatic sense, oh, if you do this, you will know cognitive science, or you will know theoretical, mathematics or biology or whatever, but much more a process of interfacing with like I really wanted to. It's been exciting because it's like, how do you get to focus actually on the trajectory and not on the specifics of like what, not trying to say what the field says, but a little bit more, how do you really focus on the trajectory itself? And that's been really fun to flesh out. And as things are a little more concrete, and I am writing things out, I am putting into words. I'm purposely avoiding showing some of that right now. But I'm happy to kind of talk more about that in the future.
Yeah.
Yeah. So
I'm
let
gonna.
me. I'll just quickly show everything else here. Well, not everything else, but I don't want to just go over this board. Any questions about that? I guess before I go into it, because
I was gonna. Well, you can do this, and then I'll talk about it for a couple minutes. But yeah, that's really cool. It's. Well, I want to. Yeah, I want to go over that in a minute, a little bit more in depth. But
yeah, I'm kind of being like I don't. There's a lot to say about it. There's a lot of like derivative stuff from this. I've realized from Frontier Map specifically that like I've realized I've had a major sense of pressure, not pressure, but like a major sense of urgency change about it because I realized, oh, like this is actually foundational to a lot of stuff I want to do in condition futures too. And I feel a little bit silly because originally it was just this sort of idea about, okay, how do we get a researcher up to speed? You know, like who has no context in his budget, how do we do it? You know, and that's I kind of want to just make that like that to me. That's like Frontier Map version 1.0. But there's other things that have kind of come into place as we're doing this that kind of bridge between like pedagogical tools, teaching tools, not just like education technology, but there's sort of bridges that go into that end. There's bridges that go into much more deeply what we've been talking about in cognition futures and the reading group too. And I'm kind of just going to allude to those things for the time being. But it's been really fun, and I'm happy to do it. And I know I have other things going on. I know we have obviously NYCWiC's kind of the priority right now, but I really want to push something out to that end. Yeah. Yeah. In the interest of time, I'm just going to leave it at that. Just to kind of show where we are. We have NYCWiC. We have Bond Sustainable AI, which I need to reply to a little bit. I think Bika's pretty much is Bika. Are we done with that now? Or are we waiting to hear
no,
back?
we're waiting back. Hear back.
Okay.
Yeah.
Same thing with A-Life, Coxside, same. I got a reply to them, and it was really kind of unclear. I think it was a no, but then it was like, well, you can still do this, even though it's what I submitted. So I'm awaiting that. This is happening. We submitted one paper. We're going to do some posters in the next few months. We just talked about this earlier. We're in the pre-season, still doing these updates, and we're still in this era. A lot of really cool Condition Future stuff. We don't really have time to get into it, but I'll say the project's going on really nicely. If you're curious about that, ask us. We're kind of studying cybernetics stuff right now and returning on things, and the project's fleshing out a bit more. So great, we're doing that. A cool, trivial moment, but cool moment. Michael Levin followed Condition Futures, so that's cool. And then this is a funny thing. Eric, who asks a lot of funny things sometimes and I like his opinions and thoughts. So what you got into Cogside? Oh, it was the last 4 years of bitter cheating for me. And then quite literally for me, actually, was I just wanted to know what happened to cybernetics.
Yeah.
And that's actually that's partly why I'm here right now, because I was like, wait, what happened to this? So that's my stuff here, the notion I wanted to say.
Right.
And I don't know if you want to talk about some stuff I mentioned, or you just want to go into your project management stuff. I'll defer to you about that.
Yeah, I think I'm gonna send the project management stuff to next week because I don't want to get into that right now already. Yeah. So I just wanted to go over quickly your idea here on I'm gonna draw like an example of this. So this kind of looks like an hourglass here from your drawing, and so this is drawing, and I'm going to put, so this is the past back here. So if we think about VR, the past are like other the original sort of platforms that we've, that have come out over time, even like precursor technologies. Like if you remember if you've ever seen the ViewMaster, which is like where you would get it was a little red headset you'd put up to your face. It's usually for kids, and you have these like little wheels that have little negatives on them, image negatives that you put light through. You hold it up to the light, and you can see like the images. So you can click through the images, and you get this story that's told in a thing that's immersive, I guess, because you have it up to your face. So there are different technologies like that were in the past, and those are of limited adoption or limited use to what we might say is ubiquity. Then we have previous examples of VR. You have different headsets, different technologies where you have hand tracking and other things. Then you have the short term, which is this window here, the now, which is this dotted line.
I was muted it, but yeah, exactly.
And so this is like maybe like the recent trajectory of like a single technology. Like we could put the development of the Meta Quest in this window. So this would be like just this technology. And I'm almost thinking this is very useful for looking at innovation and some of these things. We've talked about like AI summers and winters. Then this would be an alternate way to view this, where you have different techniques down here. Then you have like previous implementations maybe of AI specifically, and then you have now so you have specific platforms, and then let me actually finish my thought here. Right, this just is one technology, and you have a trajectory within this where you have like different decision points being made, different things being implemented, and you have. And then, so then you get out of the short term and you go, and I didn't quite, I want to make sure I understand this part of it correctly. So you're saying that you could take any one of these paths forward, like you could go away or towards.
What I'm learning, I'm trying to figure out how to, and I just put a tweet in the chat, which won't really explain this better. It's almost like, to me, I want to be able to visually represent this better, but I don't know if I can do it easily in a 2D space, because everything below the now line is kind of one way of being. The future trajectory, it doesn't really match. Like to me, everything above the now line, or everything above the short term, like near term, or the current. And in another way of drawing this diagram, which I don't have access to, I basically, instead of short term, I made it like current, or like the short term in the economic sense of the current way of doing things that won't have a major shift in like how things are produced or done, like actually short term in that sense, like the current era. And as we know, like technological adaptation and technological development kind of is all about targeting what's about to come, or like developing. It's not things that are being produced for eras that aren't the one that is now.
Right.
It's sort of forward leaning.
Yeah.
Now above that, the away or the towards things, I don't know how to represent that, because to me it's not like the left side is away or right is towards. It's more like, I would maybe describe this more as like I don't know how to visually represent it right now, but it's sort of taking a specific concept or a specific implementation or something, particularly what did I call it? I'm working on a term called like concept trajectories, I think, because it's less specific to. It's more. I really want to emphasize like a developmental approach, and so if like for using the ASPA example, like ASPA and the success of ASPA could tip in how it's drawn right now on the board. It could tip the concept of embracing VR or virtual reality, and virtual reality as like a dominant place of being or interacting. It could tip it towards that, right? Or if ASPA did really bad, or there was like the whole NFT thing, as much as I said that was sort of a potential positive, that turned off a lot of people. A lot of people laugh at that now. It's like, oh, you lost a lot of money. People are making millions of dollars in some areas for like art, but some people are like, oh, that's a complete, Bitcoin, the cryptocurrency and NFTs are things that shady people do, and you're going to lose money. Someone said, oh, they're they're the multi-level marketing of this, the next generation, stuff like that. So it's sort of like, what are these factors that influence sort of the adoption, or I would say predominance of them over time? And this what we're talking about here is sort of like one or two versions ago of this. It was just the easiest picture I had to draw. So we're kind of working with an imperfect thing here. But the discussion to me is quite relevant. And like I'm putting this, I'm basically developing something where walking, I guess, the student through what you don't see here is like some of the specifics of like, okay, where's like the debate between the symbolic and the neural network people in computer science. Like and I'm not saying this is the best way to do the map. I feel like what we're talking about is sort of one you know how like in math you can represent something like geometrically or like in the function, like the different ways of representing the same thing. This is just one facet of representing it. Right. And this view, and my aim behind this particular view is going to be one concept. Like there's one core concept in this for me, at least in how I'm working it now. Right. And so the idea of having this kind of this sort of, I don't know, representation, this visualization of the eras, and this is specific to some of like the time eras, is for one concept. And the idea will be to walk through a few of these things, and you can kind of get not only a triangulation of a concept, but like a view across time of development in the concept's development, but also having different concepts and the concept trajectories. You can triangulate concept trajectories too. And that's kind of what I'm building out. I just saw something that Amanda said, does the idea of paradigm fit into this diagram? Yes. But I mean, I would say inherently to the frontier map stuff, but it's this specific diagram as I've been fleshing it out. There are things a little bit more tailored towards diagram. Like there are some like part of what I'm building out is through going through this process of the map. Like I want there to be certain, I think I'm calling them like landmarks, or like certain features that are a little bit more customized than just here's a debate. Like no, here's like we're making this a landmark by saying XYZ about this event, right? So paradigms to me are maybe not this view that I'm making or this visualization that I'm fleshing out kind of inarticulately. Although thank you, Bradley, for doing that. It's helpful. Is more about concept trajectory. And paradigms, I think, I associate paradigms a bit more with like, I don't want to say zeitgeist, but kind of zones, or almost like I'm borrowing a little bit in my idea space from something like almost like movements in art. Like I'm kind of seeing like, oh, here was this movement, or the Baroque period. Like I'm kind of seeing there's a view that's like breaking down into periods. But I think specifically this diagram, what I'm getting at here is a little bit of developing a very, 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 very simple relativity, or I guess context, proximity, or relative nature of from the now, and understanding now is sort of the short term, and then understanding the previous, trying to get to our sense understanding the previous context or general stuff, and then kind of what was before that, like in the deeper past, and then also sort of the future means of the immediate. You could be really, really specific about this. and what I'm trying to do with this diagram is like picking the concept and understanding across these very general relational, I don't really know what to call them yet. I'm like kind of eras, or just I think about like the geological history stuff. You know, you can like, oh, the current era, the Cenozoic era, or the Jurassic era, whatever. And it's like you have, but the focus here is it's not on describing. What it really excites me is like I want to do this in a way where it's not about labeling definitive periods necessarily. Like those are great, but I think there's an important need for understanding things that are in a slightly different format than, oh, here is the connectionist era of cognitive science. Here's the era of cognitive science where the predominant, the hegemonic paradigm is the brain is a computer. Like that's good, but I don't want that to be the outcome of this necessarily. So I know I'm kind of saying there's quite a bit about this I could say, and I don't want to take up too much more time, but
Yeah.
things I've been considering as I build out these actual structures, and I appreciate being able to talk about it here. So
Yeah, no problem. I think this is something we should follow up on definitely. This is your prototype, and then now you can get to the next, versions of it. And yeah, it's a typical diagram, and definitely, this is how people think about these things. A lot of times, like, to develop an idea, you need to have your own diagram with conventions and everything.
What I would really appreciate from folks, I've been trying to look at things that talk about, I found some stuff about like concept map generation, which is a little bit more like within a specific text, or like within something, what's the concept flow within that. But also like anything that sort of papers that discuss how to map things or trajectories across time. I've been trying to figure out like some other research in the area. I found some really cool things, but I'm trying to give a little more background and say why I'm doing this and not that. And I've spent quite a lot of time with my lovely whiteboards. I'm not going to talk about it here. Like I've been differentiating why is a frontier map? Why is this not a survey paper? Why is this not just a concept map? What is it that you're doing? How are you relating to questions? Why is this not like differentiate this from the cognitive atlas process where you're just listing a bunch of terms, that Russ Poldrack has set out, or like why is it not that? Like, well, it's specifically this, like kind of what we're talking about. So it's fun because this has been years in the making, and now I have a little bit more experience, and I kind of see. I'm excited to put this out, but I'm also excited to say like the further research section of why this could go in this way, and I want to go in like plan A, and there's also plan B and plan C where these concepts could be fleshed out more too. And obviously, I'm alluding to some other things that we may know about or have talked about in other spaces, but like a lot of work has been done here, and I've kind of shown like the stuff that I'm, there's a lot more refined things that I have here that I'm not ready to show yet. So I've kind of shown the simpler, easier things to digest. The same thing too, like just to mention the tweet that I shared. In the tweet that I shared, yeah, we don't have to even talk about that.
All right.
Honestly, let's move on. So
Yeah.
thank you for that. Well, definitely more ahead. If you're interested in this project, reach out to me because I'm doing a lot of work in it, and I'm committed to getting a preprint out very soon that demarcates everything. Also, I do have implementations just to mention this briefly, we talked about this before, but I'm basically making the implementations, like the actual tools to be, tools as it stands right now. And I've considered actually, I could make this into sort of an app or some generator down the road. But as it stands right now, you could do this simply in markdown structures. You could do it in GitHub. You could do it both Notion and Obsidian are essentially Markdown based, and having a few examples therein that would show, I have implementations ready to go. It's just I want to finish like the complete theory of what it is before we do it.
Yeah.
So that's happening too, and I want to put together the package and release it all soon. But if you're interested, let me know, because there's activity there, and there's a lot of personal pressure there because I want to build stuff on top of this later. So it's like, oh, I really get this out now. So that's it. The end.
All right. I did want to get to some of the things we were talking about last week, revisiting them. I'm gonna push the project management stuff to next week because I don't think I'll have enough time for that. But I did want to talk about this paper, revisit this paper that we talked about last week, Developmental Autonomous Behavior, an Ethological Perspective of Understanding Machines. So this is Satoru Isaka, who's from Vision Del Mar LLC, which is a robotics corporation. And so we talked about the abstract last week. This is a developmental approach to robotic behavior and robotics. So, one of the things that he talks about here is that his work emphasizes principled explanations to not only the how questions on mechanisms, but also the why questions on causation and behavior development. So there's this idea of Tinbergen's 4 questions. So Nico Tinbergen was an ethologist from, worked back in the 40s and 50s. And then he proposed these 4 questions, about how and why things emerged in development and in evolution. So, he tried to link basically evolution with behavior with development. So the idea was that you have a behavior you're observing in an organism, like, he model system was baby chicks, where they would look at baby chicks and they would imprint upon the mother and they would learn things in their developmental phase, and then they would have behaviors in the adult. And so you could ask the question, how do you have a behavior in the adult? How do you analyze that? You can just take it at face value. That's one way. But it's more interesting if you look back into development and you ask, how did something get there in development? How did something get there in evolution? And so you can ask these questions, and then you can also ask why questions, like why is it there? Why is a behavior structured a certain way? And so you can also bring in evolutionary and developmental lens to those things as well. So that's kind of the idea here. When he says ethology, that's where he's kind of coming from. And so this is, there's a quote from Herbert Simon at the introduction. Human beings viewed as behaving systems are quite simple. The apparent complexity of our behavior over time is largely a reflection of the complexity of the environment in which we find ourselves. So that's, that's Herbert Simon, of course, was a social scientist and AI researcher, again, of the mid 20th century. And so, that's a view of human beings and behaving systems. And so, there are a lot of different approaches we can take to development, behavior, and thus intelligence. So, if we're talking about creating an artificial intelligence, we first have to define intelligence. And of course, the lesson here is that there are a lot of different ways you can do that. So this is the basic components of machines exhibiting reactive behavior. So there's the environment with which the organism interacts, there's the sensing, there's the processing, and then there's the acting. These 3 things are, of course, an internal model in the organism. So there's sensing, there's processing within the maybe a brain or in a physiology, and then there's acting, which is the motor or the reactive part. So, if you have a sensory motor loop, it's really this thing here. And so, this is just one way to view this. This is the most conventional way. But again, this is and then of course it doesn't mention embodiment in here too much, but the embodiment aspect would be this part of the loop up here, where there's an internal model, but it's also embodied in an agent or an organism. Let's see. Then there's kind of going through the historical perspectives. Over the years, a variety of machines have been constructed in attempts to replicate some of the cognitive features of the brain. To what degree these machines exhibit cognitive abilities is a subject of debate. So this is why, we're trying to sort of build maybe a developmental model. So the origin in classical frameworks, there's a metaphysical question of behavior and cognition, which is why is there something instead of nothing? So, it's the old argument of how do you get complexity from apparently nothing? And so this was a question back in the 4th century BC when Aristotle kind of attempted to answer some of these things. And since then, we've had people revisiting this question, why is there something instead of nothing? I mean, nowadays we know that there's, a brain that processes information. I mean, that's the current sort of consensus on what there is. Of course, there are other views on this. The brain maybe doesn't process information. In our cognition futures group, we've been exploring people's perspectives who say that the brain is a resonating organ, or that it basically reflects the environment. But the basic question remains. You have maybe things that are generated by a brain, like autonomous behaviors, but maybe they're innate behaviors, but there's a role for environment there as well. And so that basic question has been addressed many times over. That's where we come from, though. And then, kind of getting into some of these modern frameworks, neuroscience, a neuroscience emerging from a synthesis of anatomy, embryology, physiology, pharmacology, and psychology. And so that's, one, I guess neuroscience could be defined in a number of ways, but that's how he's defining it. Computing and information science emerged from empirical analysis and synthesis of physics, dynamics, electronics, communication, control, and computer systems. And then, of course, we've talked about cognitive science being a synthesis of different areas. So even the way we look at this, we look at the brain, we look at behavior, it's always a synthesis of different modes of inquiry. So, when we talk about, we want to model things like the brain, where are we getting our information about what the brain is? Is it from neuroscience? Is it from, philosophy? Is it maybe from computing or computational views of the brain? Computational neuroscience versus, say, like neuroscience, like neurobiology. So, those sorts of perspectives make a difference because you're synthesizing different areas of knowledge. And those areas of knowledge, again, have their own sort of, they reflect what those areas are interested in, what they're abstracting away from the data. So anatomy, for example, you have an interest in all these parts and how they're related. Embryology, you have an interest in how things are shaped in development and so forth. And so, it really, I think, and this goes back to what Jesse was saying about the sort of the trajectories of ideas. When we talk about something like developmental approaches to intelligence, we have to define kind of what we mean by development, because there are different ways that we can view development. We can view that as primarily a embryological phenomena, primarily a behavioral phenomena. There are ethological approaches, there are psychological approaches, there are even different approaches in philosophy. So it really depends on we really have to tease out those origins and make sure that we're being specific as to what we're going for here. So I'm trying to find some interesting things. He talks a lot about Turing in this article, and I don't know if there's any link between Turing and development, but we talked about the thing that Turing did on development and developmental approaches, I think last week. So there is this, discussing just a general overview of Turing. Then Norbert Wiener theorized in his book Cybernetics that all intelligent behavior was the result of feedback mechanisms. and proposes a study of how humans, animals, and machines control and communicate with each other. So this talks about cybernetics, and it's kind of an interesting thing to bring up cybernetics here because, what would be really interesting is if we thought about cybernetics from a developmental perspective. I don't know if that paper exists. I think, if we had like like cybernetics is basically feedback.
What was the paper that doesn't exist? Cybernetics and developmental something? Or
Well, okay. Now I shouldn't say that because we actually in DevaWorm we did a paper several years ago, and in fact Rob Stone, who has worked with the group before, has done some things with cybernetics and the cybernetic embryo. But what I'm saying is that I don't know if this paper exists, but approaching cybernetics kind of from a developmental perspective. In other words, you have feedback, right? You have the cybernetics, and you know that like you have feedback, you have control, you have communication. But then you also have this developmental aspect, which is like, there's a process that unfolds. So you have this steersman analogy where you want to steer the system in a certain direction, right? And then what if we took like a system that was like started at a single cell embryo, say, or it started from like a set of primitives or like a set of innates, and then we started to build it up with like acquired knowledge or acquired features. And this all had a cybernetic aspect to it, in that there was feedback, there was an input, there was some processing, and it would steer from one direction to another. This is something we didn't really do in the cybernetic embryo papers, but this is something that would be in that spirit. And if you don't know what I'm talking about, it's probably because I've not talked about it before in this group. So, but we have done some things of what we call the cybernetic embryo, but there are a lot of things to follow up with on that. And one of them is this idea of having like a developmental process that's explicitly described in terms of cybernetics. So, using those kind of analogies, using those kind of approaches to get to, something that is where I can describe development as a cybernetic phenomena, but also that I could use a cybernetic model as sort of a generative model that would push out like some developmental outcome. So like, you acquire things in a certain order, and you have a phenotype that's developed, and that sort of thing. So I don't know if that paper exists except for the cybernetic embryo work that we were doing a while back.
it looks like we'll have to revisit that. Have you heard from Rob recently? I know he was like kind of showed up a bit last year.
Yeah, I haven't heard from him in a while, but I'll check in with him.
I think we're returning sweeping back that way anyway, so it'll be. We might be talking about some of this stuff, but yeah, cool.
Yeah. So this is a really wide-ranging review. This he also brings up developmental robotics. If you're familiar with some of the work they've been doing in developmental robotics, and this is where they're using development to sort of build robotic systems. So they're a set of design principles, basically. There are a number of different approaches. There's Krickmar and Edelman. That's an old paper from the 90s, talking about kind of from a more neuroscience standpoint, about brain-based machines, how, there are a number of design principles there where you have a physical instantiation. You should have like a simulated brain with a detailed neuroanatomy. Pfeiffer, from a different era, a little bit later on, suggests the following design principles for autonomous cognitive agents. So this focuses more on like an ecological point of view, and kind of getting into some of these things with like subsystems and subsumption architectures, where you have like things that are nested and things that are in subsystems that interact. And then Cangiolosi and Schlesinger, which is a little, maybe about the same time. This is in the aughts, maybe. They have a set of design principles for developmental robotics. So that means that development is a sort of dynamical system. So that's, people have used dynamical systems, but not necessarily cybernetic systems to characterize development, which means you're looking at the trajectory, but you're not really getting at the feedbacks too explicitly. That you have nonlinearity, you have stage-like development, you have open-ended learning. So these are like different areas where they're kind of in this area of developmental robotics, developmental agents. And then the field of developmental robotics itself emerged from as a reaction to the inability of traditional robot architectures to scale up to a task that required close to human levels of intelligence. So this developmental robotics area was an attempt to sort of get at the shortcomings of AI as you tried to build a general AI and you couldn't get to, the point you wanted to get to. People would say, well, maybe we're needing to take a different approach. Maybe we need to add in like development, or, there are also evolutionary approaches where people make the same arguments. And so, I don't think the point is in some ways it's to make a general human level intelligence. In other ways, you're adding in a lot of things that maybe should be there. If you're thinking about like building a cognitive architecture or a robot or a autonomous cognitive agent. And so do we really need to have all these developmental principles? I think we do, but we may not. It's this work by Hugo de Garis and Ben Goertzel. They did some surveys where they talked about cognitive architectures and large scale brain simulations. They're not there yet. I mean, they've argued that we should have like large brain simulations, and those will get us to AGI, but those aren't really going to get us there anytime soon. So this is why we're thinking about development and kind of having this sort of bio-inspired approach, but not quite everything you'd find in a biological agent, not quite these large scale neurosimulations. So yeah, so this goes through like also. So what is intrinsic motivation? This question has been heavily investigated and debated over the years. So intrinsic motivation is something you'll maybe want to approach with a developmental framework. Ryan and Deci have provided well-cited definitions. Ogier and Kaplan, which I think we talked about this paper several weeks ago, point out that current definitions and treatments are not satisfactory for computational models. They wrote the most pragmatic approach to intrinsic motivation from a computational point of view is maybe to avoid trying to establish a single general definition. So, again, with the design principles for developmental agents of different stripes, maybe we don't want to take for, say, like intrinsic motivation, which is usually like things that are generated by innate mechanisms, like thirst or hunger, maybe are intrinsic motivations. You can have those kind of operational definitions, but to define it in sort of a theoretical view is a little harder to get at. And so that's what they're getting at here, is that if you want to build a robotic system, a simulation, it's hard to say that all intrinsic motivations are equal, that they provide, you can have like a overarching computational framework for it. So, this, again, we have a lot of things going on with development, with ontogeny, which is what some people call development ontogenetic behavior. And they just this is a really long, I'm not going to go too much more into it, but, this just really reviews a lot of literature and a lot of what people have done in the area. So I think we need to maybe do something with this. I think it would be nice to kind of extract some of the strands out of this. It's definitely for like a frontier map, or like this would be useful.
Absolutely. I was kind of trying to sort this out, and I saw like it looks like it was published this year. Like it looks like it's really new.
Yeah.
Which is it's been hard to find new, coherent, comprehensive things in this. And I would absolutely I want to take a deep between this and the Vanessa Lux article. I feel like those two are like prime candidates. At least personally, to be transparent, things I really want to study are about like those two are like really high on the list. The only other thing I can't there's a related thing that I know about, but I can't say much about because it's not really happening. And I mentioned to Bradley a little bit, but like there are some other projects and collaborators doing things that I know about that are cool. But honestly, this and this paper I think is probably the most on point one. And there's I haven't really looked at it other than we'll talk about it. And there's so much stuff that we haven't gone through, and I feel like I don't know if we want to. We can mention it in condition futures too, but also like I guess I'll put it this way. I don't know how much main or lab time we want to devote to that stuff, but for me, I see this area as stuff I really want to elevate as like stuff that I'm interacting with and doing and stuff in that space. And I don't know, like I don't know like what it fits under. Do you see this as basically related to like developmental AI?
Yeah, I
Or
think it actually does outline a lot of the like past attempts at this. Like it does give a lot of like linkage between different approaches. I mean, I don't know if it looks like it's like 60 pages long, so I didn't get to the bottom and see if he's making specific recommendations. But as a like a framework or to think about like where this has gone in different ways is really fascinating because you get to see like, okay, there's this area where people are interested in this topic, and then there's this area where people are interested in this other thing, and there are different interests going on where if I want to design a developmental robot versus like simulate a brain versus do like a cognitive agent that's maybe developmentally inspired, they're all different things, and they have their own design principles and their own sort of precursor things that you want to be interested in.
yeah, so there's a lot. Like I would, to the extent of like I wouldn't. I'm tempted to basically like break down each of the sections into like a small blog post kind of a thing. Like I would want to get really nitty gritty and then build from it and incorporate a lot of the like I can't imagine what the references are. Like the references to those things would be like if we just took one page. I would wager fairly strongly like you could easily do 6 months or 9 months or 12 months of just going to the references on paper. A paper like that would have so much, So, really cool. I hope we talk about it. My Notion space has been glitchy, and thank you, Amanda, for taking notes there. And I'm trying so hard to make a stub for this paper so we can reference it and other things, but that'll happen one or the other. Yeah, cool
I
stuff.
think I made a stub. I think I just did that successfully.
Well, it's giving me such a hard. Yeah, it looks like you did.
It was giving me a hard time too.
Yeah, like I couldn't get through the app part. You did it. Great. Thank you. You get your Notion abilities are ever increasing. So cool. Yeah, I don't know. I would keep gushing about that and other things, but I don't. I have one question that's unrelated. Otherwise, I imagine you want to do other papers or something, Bradley. So
Yeah. So Morgan, one last chance? Did you want to do your overview?
Well, it's been good to go through and review the week. I don't know if I've got a great overview, but I do want to just highlight Amanda's comments on the GPT-4 AI.
A legal one?
Henry. Well, just the I think what's the best? Yeah, every problem with AI is a problem with our current economic system. I thought was was a terrific comment on the letters that have.
Where was that one, by the way?
This is to discuss.
Okay.
So yeah, but I and Amanda's got more on it there. But I thought that's actually probably the best contribution I've seen on the topic.
Yeah.
That sounds like I'm so certain, but I guess I don't mean it with such certainty.
Oh, okay.
But I've yet to encounter discussion of ChatGPT or AI taking jobs that like really makes the case that AI is like a novel threat. I don't know. I'm happy to keep talking about this.
I think you got that across in your last comment, which was, in what sense has the development of civilization ever been controlled? Right? Like, have we, had such a good idea of where we're going and how we're going to get there? So yeah, I like both the way you stated it and dressing it as a topic, or perhaps a more fruitful discussion topic than just let's stop this. And when has that ever been productive?
Yeah.
It's there's a lot of great things from that too. But keep going. I don't want to interrupt you.
Yeah, no, then I know I've dropped a whole lot of events in event discussion. That's partly because I'm just seeing these for the first time. And yeah, just the Gail Verquois paper that I think I put in Data Sci ML, I hope. I was having trouble finding that particular one, but philosophy measurement. Yeah.
Okay.
So
yeah,
maybe that definitely needs more time to discuss. But it does seem like it's going to be a really fruitful discussion of causality measures.
Yeah.
Okay, I'll put that link in here. Is this the risk ratio odds? What's the difference? That one?
Yeah.
How to generalize causality? Best way to generalize causality measures.
No, this is all really good. I'm glad.
There's some great stuff in brain organoids that I really like the link. Thank you, Amanda, to the Michigan meeting this week.
Oh yeah.
Oh yeah, I'm not sure if I didn't make it to that. I'm not sure if it was recorded, but it was on Zoom, so it would have been easy to record. So hopefully.
Yeah.
Yeah, this is great. The moving cells using ultrasound is really interesting too.
Well, yes, yeah. I mean that's only one of who, because I think Jesse knows him. Logan Thrasher has been on a just great streak of papers recently, all biotech, nanotech focused.
Yeah.
And that was that was just one of like maybe four. I thought it was maybe getting too technical, but again, just getting at some of the things that you're going to want to be able to do when studying organoids or studying 3D objects, where development, where actions taking place heterogeneously, and you want to be able to move things around and better control them.
Which one? Do you remember where that paper was about the ultrasound and brain fluids? The one was the.
I think I dropped that in organoids.
Yeah, it's in organoids.
Yeah. Yeah.
I think bioevolution is the other channel. So yeah, that was where Amanda put the event.
Yes, well, and certainly that does relate to one of Logan's papers. He had an interesting artificial cell system for studying evolution, or the evolution of peptides.
Oh wow,
It was
yeah.
a really interesting paper. Yeah. So it was totally like a biotech paper, but an interesting, research platform.
Oh, I think I saw this. Yeah, this was the one with where they're synthesizing peptides or something.
Yeah,
Yeah.
it's like an ACS paper.
Yeah, that's
I
it.
yeah, I was kind of going down the rabbit hole checking out threads here, but I would love to just go, check Logan's like Facebook or LinkedIn, where he's got all his papers. I assume Twitter too, but
Yeah, Logan's cool. I'm gonna be very vain and pull up a picture. So people could be talking about it. Oh, it's not on this computer. Oh well. Sorry, you guys can keep talking.
Oh, yeah. So I'm gonna finish up here. I'm not gonna get into. I wanted to get into some. Last week we talked about some papers in the biological computing area. We talked about this logical circuits for fungi, mining logical circuits in fungi, which was, I don't know if we wanted to revisit that, but this is, it kind of gets into some electrophysiology. It gets into electrophysiology in fungi, which is not, of course, doesn't have a brain, but you have this ability to process information, and you can actually use Boolean functions. And the claim here is that they're Boolean functions that are replicated in the fungi. So, you have these organisms that don't have a brain. They're processing information as we understand it as in modern computational science, and then we're able to model this using cellular automata, which are these models that can reveal universality of computation. So, there are these rules of the cells as they're interacting, and they're producing these rules that are descriptive of what rules are occurring in other types of systems. That idea is, although it is controversial from like the perspective of, say, like a neuroscientist, uh, you know, it's something that is pretty common in computational science. So, this is an interesting. A lot of the stuff that Andy Adamatsky does is really interesting. He does a lot of stuff with fungi and with slime molds, and looking at like how they compute things. So this is a very interesting piece of work. Um, there are other things that what did I pull up here? So yeah, there are a couple other papers. I don't really want to get into this one though. I will get into computing within bacteria. So I think we talked about bacteria. So I pulled this up from biosystems as sort of a way to kind of go down this rabbit hole a little bit more. So, bacteria, of course, also don't have brains, but they have a physiology. They live in colonies, and so what are they doing here? So this is computing within bacteria, programming of bacterial behavior by means of a plasmid encoding a perceptron neural network. So a plasmid is something that you can it's a piece of DNA that you can insert, and it does, you can actually build it to do certain things. So, this is at the level of DNA and producing an output. So in bacteria, they have a circular genome. You have, you can insert this piece of DNA using a plasmid, and then bacteria can also be plasmids in like mammalian cells. So uh, you can have a plasmid that way as well. So the abstract reads, in nature, bacteria exhibit a limited repertoire of behaviors in response to environmental changes. Synthetic biology has now opened up the possibility of programming cells or unicellular organisms in order to enable them to perform certain tasks, which would allow the programming of intelligent bacteria. So what we have is the circular genome. We can insert plasmids into the genome. We can program that bacteria. A lot of synthetic biology is sort of concerns programming bacteria. So what they'll do is they have taken some bacterial species and worked with their genomes. Sometimes these genomes are they're very optimized by nature. So you have a lot of genes without a lot of junk DNA or regulatory regions. And so what they can do with that is they can knock out non-essential genes, and they can end up with an essential genome. And that essential genome then just allows the bacteria to sort of have basic metabolic functions. And then what they can do is they can put in new genes that allow them to do certain things. So you can build a bacteria that is specialized to clean up or remediate toxic sites, toxic waste sites. You can design bacteria for medical purposes, and you can have specific control over those bacteria because you can control the genome. So this, you can't necessarily do that in mammalian cells or in animal cells. You can do it in bacterial cells because of the structure of their genome. So this is what they mean by programming intelligent bacteria. Many of the theoretical ideas that Lieberman proposed last century, for example, a seminal idea that the cell is a computer, are now being put into practice with bacterial colonies in both wet and in silico experiments. These bacteria may one day be used to solve a wide range of problems whose solution requires their adaptation to external changes. They're within a bioreactor, which is a type of cell culture environment where they can grow up bacteria, organ or tissue of a patient, or through the design of microbial synthetic consortia oriented to their use in bioprocesses to produce medicines, biofuels, or biomaterials. So bioprocesses are just being able to generate, you can use bacteria as biofuels or biomaterials. You have to grow up the bacteria, you have to engineer them in a certain way. And so that's what that means. In this work, we show the possibility of programming synthetic bacteria with a previously trained perceptron neural network. First, we illustrate how a colony of bacteria endowed with a perceptron, so they build like a perceptron out of the bacteria's, from the bacteria's genome. I guess they engineered the genome so that it forms perceptron. So they are able to do this, and they're able to solve an optimization problem in silico, which means in a simulation. So they have an optimization problem they're solving. Secondly, we study by means of in silico simulations how a perceptron can be applied to program behaviors in bacteria, leading to social interactions and to the formation of complex communities that in the future would be useful in biotechnology. So this is a lot of simulation. You can simulate bacterial genomes. In fact, you can see what the effects are of certain genes being plugged into the genome, and they're doing a combination of in silico, and they're doing it with sort of future directions and things like that. Finally, we go a step further and study how the above perceptron designed to program bacterial behavior is implemented in a genetic circuit designed for this purpose. So now they're putting it into a genetic circuit, and then they're engineering it into a plasmid, and they're able to build this thing in biological world. So they talk about how many living beings exhibit behaviors and learning. They define learning as organisms whose responses to a stimulus are modified based on previous experience. And they kind of go through some of the things that we see as learning. And in bacteria, slime molds, and other unicellular organisms, they exhibit behaviors encoded in their genes. So that in these organisms, their behaviors are encoded in genes, almost exclusively, but you can also, engineer those genes to get them to learn things. So this is how they're approaching this. The result is that these organisms behave in a manner comparable to sensory motor agents. So this is a reference to this. So they're making this analogy between sensory motor agents, which are agents that have that sensory motor loop, and bacteria or slime molds or fungi, where they do this sort of, they have this genetic controlled behavior. And so doing the genetic engineering will get you to this sort of sensory motor loop interaction or modifying that loop. And so at present, experimental evidence suggests that microorganisms are intelligent sensory motor agents. And so they talk about some of the stuff with Viscerum, which is of course I don't know if they're citing Adamatsky in here, but he's done this sort of stuff. That Physarum, which is a slime mold, is capable of developing a type of learning called habituation. So that's where they can habituate to a certain environment, and is also able to solve the problem of a maze. So they were able to build a slime mold computer in the context different from that of natural computation. This group here has proposed to reconsider learning capabilities in bacteria by drawing a parallel between prokaryotic behavior, which is bacteria and eubacteria, and neural learning. So bacteria don't have brains, of course, but they can behave collectively, they can behave and have habituation. So there's this parallel between that and neural learning. And so bacteria exhibit things like chemotaxis, which is this movement towards chemical gradients and away from other chemical gradients. So this is something that, they have signal transduction networks and they have these chemotaxis. So those are very neural-like. And so that's the parallel to drawing. And so they kind of go through a lot of this, talking about sensation and how bacteria can sense the environment. And since you have that genetic control, you have a very tight loop that we can exploit. And so they kind of go through some of these ideas like minimal cognition. And, we've talked about that where you have cognition where it's very basic. You don't have to have a brain. You can have non-neuronal mechanisms, but it does sort of behave in a cognitive way or an intelligent way. And so they kind of go through the experiments here. They have a neural network that they build. So they do offline training of this neural network. They adjust the weights of the connections, and they are able to generate a binary response that gives you this result. So basically, they're trying to generate responses that mimic what the bacteria will produce. And so they can put different genes in, generate different responses, and then those responses are encoded in the neural network as a series of weights that produce a series of binary sequences that mimic the behaviors that the bacteria will produce. So like you know which genes will produce these binary strings, and so there's this connection between what the network is producing and what the bacteria is producing as its behavioral output. And so and then they kind of go through some of the so a perceptron here is a very small neural network with a single output. So that's kind of what they're mapping to what the bacteria is doing with its interactions with the environment and its genome. So I don't want to go too far into this. That's enough for today, I think. But I just wanted to go through that paper, or that set of papers. There was one more paper in the group, but I'm not going to get to that today. So I just wanted to revisit that.
Yeah, as usual, if you can share the links, that'll be great.
Yeah.
I had an unrelated question, but I don't want to. It's something we can more take offline, but I'll mention now. But unless you want to comment on the papers first. Yeah, actually, I'm going to save my question for later too.
Okay.
So.
All right. Well, once again, great meeting, and I hope we, if things to follow up on, I'll send out the papers. I know some of them are follow-ups, and I didn't post them maybe last week, but I will this week. So, okay. All right. Well, thanks. Have a good week.
Yeah, talk to you soon.
Take care, everybody.
Thank you.
All right. Bye.
Bye-bye.
Take care. Bye-bye.
Bye-bye.